Hi everyone, my name is Krishna and I'm working in IT for the last 16 years as a system manager. So today's topic is building scalable applications with MapReduce. So what do you mean by big data? So when you say big data, just the term says big does not mean the data is big. That's why we are calling big. There's a criteria at which we define that parameter big as well. Now, when you say big data, it is actually defined by three parameters basically, which we call three V's. One V stands for velocity, another V stands for variety, and another V stands for volume. So when you say volume, volume is all about the data size is too huge. When I say too huge, it will be in petabytes and trillions of petabytes kind of. That means the volume is so huge. To give you examples of which kind of systems have that kind of petabyte volume per day, Facebook, WhatsApp, Instagram, these all actually have petabytes of information going now and then. In a day, if you look at the average size of the data they will be reaching per day, if you look at Instagram, which are more popular these days, or any other of social media networks, they are in petabyte size. So that's like a big data kind of one of the parameters it matches to that. The another thing, like I said, variety. So variety is nothing but the data will be in different formats. So when you say, if I take an example of Instagram, right? Like in Instagram, you can put a message, right? That's a text message. In Instagram, you can put a video. That's a video file, right? You can put a audio. That's an audio file. So each of these three, if you compare, they're all three different formats of data. One is text, another is video, another is audio. So your big data system, when you call, it should be not only capable of just handling the high volume of data, but it should be capable of dealing with these different types of data also. That is what I mean by variety. Now coming to the other one, velocity. Velocity is nothing but the rate at which the data transfers is so high. That means you will not get time to, by the time you want to start processing and take time in 5 minutes. Let's say you want to write a program and want to deal with the data. Within 5 minutes, you see there is a lot of data coming in. You cannot, you cannot have time to do all that. That means the data transfer rate is so high. So that is called velocity, the speed at which the data coming to you, like Instagram, Facebook, all the social media networks. Generally, as you know, the the data transfer rate to the servers is very, very high, even Twitter. So these kind of things, particularly like when you have variety, volume, and velocity, if these three parameters are matching, that's where you call a data as big data. It's not just based on the volume. Okay. So now, given that we know about what is big data is, why we are talking about it, first of all, these MapReduce or whatever big data applications when we call, these are all there to process that, because we are saying there's lots and lots of data and you have to process it, and the data comes at so fast rate. How you enable your system so that they can process at the same rate which is expected, and how to process it in real time, right? So that's where these kind of application comes in. And today's topic is about that. Like we are going to talk about one of the system which can handle this type of big data data sets. So this is our agenda. So we'll understand about Hadoop MapReduce. You can consider Hadoop is like one of the platform to an operating system platform to process these big data. We'll also talk about one of the heart of Hadoop called MapReduce and how it is architected and all that. And we will understand about the advantages of MapReduce. And we will also understand about the approach it takes by an election example, saying how generally happens an election, how generally an election happens, and how MapReduce deal with that in a different way. Then we will understand about one of the components of Hadoop called YARN. YARN means at another resource negotiator. So that is one thing we will look at what actually it does. It's more of a scheduling and a workflow kind of model. So that's the topic for today. Now let's understand the concepts. So basically, when I say Hadoop is the core platform, or you can consider like a core operating system for processing the big data at a high level, I mean, 1,000 feet high level, if you look at, it basically consists of two components. One is for storage, another is for processing. That means one particular set of components will be dealing with processing the data, which is basically a MapReduce. Another set of components deal with storing the data, because in order to process, you need the data to be stored somewhere, right? That's where being stored in this HDFS. This is what I'm saying. This is the one of the Hadoop MapReduce is just the processing component of Apache Hadoop. And the way it processes by processing the data in parallel. And one more thing here is generally these Hadoop applications and all really works well when your data is so huge. But let's say you have given 10 numbers and asked it to sort, it will take a lot of time. The 10 number sorting might not be a big deal. But one thing you have to understand is these particular systems are made to deal with high volume of data. But if you have used for a very, very small volume of data, you will not see the response. You will see the response very bad because the system is not made for it. Because generally what happens whenever you start in Hadoop and all, there's a lot of configuration, there's a lot of setting has to happen. So irrespective of whether your data is very, very small or big, the same set of steps will happen. So you have to use, so what I'm trying to say is you have to use the right tool for the right use case. So if your data is very huge, then only you will go for these kind of systems. And most of the time, if you see on the application side, Hadoop MapReduce, these particular things are used mostly for offline job processing. Something like if you look at advertising. So advertising systems, most of the time, some of them are real time, but most of the data processing happens at offline. So those kind of things, people generally use Hadoop so that they can process faster. And the data is not needed really at a real time at a very rate. There could be some, but most of them is offline processing. And Hadoop really works very well in the offline kind of systems. Now, where and all we can use our MapReduce. So MapReduce is one of the component which actually does this entire Hadoop processing part of it. So you can use Hadoop to doing indexing, searching, classification, or any kind of recommendation or analytics, all that. Like for example, one example, if you see Hadoop being used is if you see Amazon whenever you log in, and once you say these are the products you bought it, maybe you try to log in 2-3 times like that or once or twice. You might be seeing as soon as you log into Amazon, it might be recommending certain products to you, saying, hey, there is a bicycle you were looking at last time. Do you like there are new models coming in? Or hey, this particular dress you are looking at, we got some offers on this. Something like that, you will get a personalized view of Amazon page for you. The reason is they are actually looking at what you are liking it and personalizing your experience by mining your data. Over a period of time, not only for you, a lot of customers, they keep looking at it. And again, in recommendations also, there are different ways. So using that, they are actually mining all your data and understanding what actually customer is looking for and doing all that. So now how it is all happening. These are all on the back end. It is all completely based on these MapReduce because the data is so high, right? If you ask today, how many customers Amazon have, it will be in millions. So those millions data it has to process in the back end at the same time providing recommendation. It's not an easy task. So it's a very, very huge data. And the features of Hadoop, if you look at, you can use it for large-scale distributed systems. Large-scale distributed, Amazon is a large-scale distributed example. You can use to parallelly program it. Parallelly programming in the sense concurrently processing multiple things at a time. And the basic functionality of Hadoop is based on the MapReduce. We will learn about how that MapReduce works. And this MapReduce is implemented by different companies in different ways. Like we have Apache Hadoop, which is actually the main vendor who started this. Then Google has its own MapReduce. And apart from that, if you see today in cloud computing also, you will see the Hadoop is available. If you want to look at in cloud computing, I mean, I worked on the AWS side. And if you want to work on cloud using these MapReduce kind of thing, the service name is AWS EMR, Elastic MapReduce. So that's the name for this particular MapReduce in AWS world. Maybe in Google, it might have a different name. So in cloud computing also, these kind of services are offered. And there are different design patterns being used. When I say design patterns, the architecture design patterns used to build these MapReduce. One is the summarization, another is classification, and another is recommendation. And there is one more. Let me get that here. Yeah, analytics. So summarization is basically used for all the indexing things, classification for getting the top records, and recommendation for sorting the data, and analytics for joining and selecting the data. And if you see Apache Hadoop, right, like it is not just like when you want to use Apache Hadoop, you have to use only on the platform where it is built. In Apache Hadoop also, you have again different I would say programming models available in order to deal with this big data. Let's say, for example, you like writing SQL queries. I mean, you still want to make power of you still want to use the power of whatever this Hadoop system is, but you don't want to do the classical way where you write a shell script and all. Now you like queries very much, SQL queries and all. So for people who like SQL query very much and they want to do this MapReduce stuff and all, they can write in Hive. Hive is one of the, you can consider like a programming language kind of model where you can write SQL queries, and those SQL queries internally will be converted into this MapReduce. And the things will happen in the same way, like parallel processing, all that MapReduce stuff. Similarly, there is something called Pig, which is what developed by Yahoo. And pig is where they have a separate scripting language kind of thing where you can write certain tasks and those tasks gets converted automatically to MapReduce. So at the core, it is your MapReduce who does the processing. But on top of it, these guys have built different applications. You can consider like Pig, Hive, HBase, and HDFS, where using those, you can write tasks based on whether you write a programming, whether you like querying, whatever. It's all based on you. You have different applications being built. And irrespective of whether you write in Pig or Hive, the processing speed is completely dependent on MapReduce, but not on the application where you wrote this. So those are all different, again, options you have available in case you want to use the core power of MapReduce, but using some other application based on your interest. Now, what are the two advantages of MapReduce? So generally, one, as you see, the processing become very fast because we process the data in parallel. We will not do the processing in sequential in nature. Like for example, if I ask you to count, if I ask you to sort about 1 crore numbers, maybe what we will do is we will take one number each and we'll do some kind of selection sorting or bubble sorting. We will do something like that, right? By looking at each number. But the way this Hadoop does is different. So maybe the Hadoop, the way it might be doing is this 1 crore data, it might be splitting into 10 lakhs to each of the servers, and that particular each of the servers might be doing the sorting. And at the end, all this 10 lakhs data, so there will be 10 servers, assuming each one take this 10 lakh numbers. All these 10 lakh numbers, after sorted by each of the individual hosts, they will be aggregated further. So to give you a high level, if I want to talk where map fits and where reduce fits, the first part of given 1 crore numbers I have asked you to sort, and you are using this MapReduce, the 10 servers which picked up, and these 10 lakh numbers by dividing 10 lakh into 10 will become 1 crore, right? 10 lakh into 10 will become 1 crore. So that 10 lakh of each map to each host is what the mapping part takes care. And finally, once it runs and sorting all that, that's where all this reducer and all happen. And finally, aggregation, where you combine all the sorted, each of these hosts sorted those 10 lakh numbers, you will further aggregate. And that's how it happens. This is a very high level picture on how things happen at MapReduce. So now, generally what happens is, even though it is parallel processing, if you want to understand how this happens, generally, if you want to process the data, what we do is, we actually move whatever the data required. Like for example, if you want to work on the machine learning and if you want to work on a lot of data, generally what you do is you will say, I will actually put the data in memory so that my machine learning algorithm can process it. That's how you do it, right? That means you are getting the data closer to where your processing is happening. It means in this case, it could be a program, or in some other case, it might be a tool, isn't it? So just like that, that is what generally we do. But Hadoop takes a different approach. Rather than moving data towards processing closely, it actually does the reverse. It moves the processing to data. That's how it follows it, so that the processing is very fast. We will see it in the example how this really helps. So traditional versus MapReduce way. So this is the election votes counting example. So if you see election vote counting, you have booth A, booth B, booth C, booth D, booth E. Each booth is actually responsible for counting votes, right? And you have a result center, which is like a center where you actually aggregate all the results and do it. Now you can do this in two different ways, right? Now, one could be where you move all the votes, okay, whatever vote that you have collected, you move all the votes to this particular result center and ask the counting to happen there. That means in each booth, you are just taking the votes, but you're not counting. All the votes and all counting, you move to the result center and do it. Now, here in this case, how many we have? It's 5. What if there are 100 booths? Each booth are just taking the votes into consideration and having the counting happening at the result center. So obviously, you will see over a period of time when the number of booths increases, the number of the amount of work this result center people will get will be huge. And there will be a point where you will not able to provide the results immediately because the result center is overcrowded with all this counting, right? That's what's going to happen. Now, that's what traditionally we do. Now, how this MapReduce way will happen? In MapReduce way, what it says is, rather than you just collecting the votes, maybe you should count votes at each individual booth. Now, what happens? Booth A counts whatever the votes it has got from its side. Booth B does the same. C, D, E, and everybody does the same. Now they have counts of votes in each of their booths. Now what they do is overall these all they combine and take to a result center where result center will finally aggregate. When I say aggregate, summing up all this. So it will be easy. It will not be overcrowded. Even if you increase to, let's say 1 lakh booths also, it is all about the total count is what they have information for each individual booth. So it will not be an unscalable approach though, right? This is exactly what MapReduce also does. So like I said, if you consider there is an input coming in and there is an output in between, if you see the core heart of the entire system is your MapReduce. And what map does is, like I said, allocating the counting boards and getting the count in each individual booth. That's what map phase you can consider happening. And in reduce is where once you get the individual votes, booth-wise counts of the votes in that particular booth, finally aggregating that is what happens in reducer phase. There are a lot of things happen. I'm just giving a high level idea. So generally, if you look at a MapReduce program, it is like a key value pair kind of thing happens. So we will see one more example. So if you see, how do I count a word, so we are going a little further. Now, how do you count a word? Like, let's say your input is like this. The input is something like deer, beer, river, car, river, deer, beer, deer, car, and beer. So whatever the count you have to do is, you have to say the total number of words, the frequency of words. If you see here, deer has repeated twice. So you have to say deer 2, you have to say car 3, and you have to say beer 2, and you have to say river 2. That should be your output. Now, if I had given this program to a MapReduce, how it works. So first what it does is, it does the splitting. In terms of, again, the splitting also might have its own logic to decide how to split it. Now the splitting will happen where we say that, okay, we will split this particular input into 3 parts, and each of these 3 parts will be sent to mapping. And in mapping, if you see, it will have some information about, okay, there is a deer 1 time, beer 1 time, river 1 time, and how actually would have further sent to shuffling. So these parts are part of the mapping process. So once it identifies there's deer 1 time, beer 1 time, and river 1 time, it further actually in the shuffling phase, it further identifies, okay, beer, how many ones are there? So you see beer, one is coming from here, and there is another one coming from here. So it is beer, 1, 1, which means beer repeated twice. That's what it means. It's just creating a kind of a list of, just like a tally, list of tally marks saying how many times this beer has come. Similarly, in the case of car, in the shuffling, it identifies there is a car, and car has 1 car coming from here, another 1 car coming from here, and there is 1 more car coming from here, right? So that means 3 ones, which finally counts to 1 in the reduce phase. So this phase where you're seeing mapping and shuffling, this all happens in the map phase. Similarly, the deer also, 1 deer from here, another deer from here. Similarly, the same river. So now you have individual word-wise information. Now in the reduce phase, what you do is you just aggregate them. This 1 + 1, 2, 1 + 1 + 1, 3, 1 + 1, 2, and 1 + 1, 2. So that's how you get the count. And final result will be the overall summary of these things. So this is basically the reduce phase of it. And this part, shuffling, mapping, and splitting, generally goes into map phase. So if you see, generally when in the big data also, when you apply, it is very important that you have to be, when the data grows, there are certain times you have to tune your mapping parameters, because these MapReduce are actually written in Java. So there is a JVM internally involved, which actually does all this processing, and you have to tune certain JVM parameters, sometimes the JVM memory, and sometimes you have to increase the reducer memory on the reducer side. Sometimes you have to increase the mapper memory. These are all by default, whatever these systems, the tools come with, they will come with some default values. Which they think will work best, but sometimes based on your use case or based on your data size, you might need to be equipped with those knowledge on how to change it, and based on that, you have to tune those parameters. I'm just giving the real world scenario, how actually you take care of these things. So like I said, MapReduce using YARN. So YARN comes under your, YARN is basically yet other resource negotiator. YARN comes under your processing side of things. HDFS is on your storage kind of things. And where in HDFS, you have something called name node and data node. So data node is where your data resides, and name node is where your all the processor, all the host information and all will be there. And in the YARN, you have something called, one is resource manager, another is node manager. Node here, it means a server. You can consider it like that. server is like one host. And generally, if you look at the components which are involved in Hadoop MapReduce YANs, like this is how the phase goes. Once client submits a MapReduce job, that means he gave an input and he triggered a job. Then the resource manager will be there who actually takes things at the cluster level. And then when there is a node, per node will be there. And there is a node manager who has one data node and he monitors the resources on that data node. And you have something called history server as part of YAN, who actually maintains information about the submitted MapReduce jobs, and if there are any terminated jobs or if there is any in progress job, all that history server you can see from the history server. And you have application master, which is one for the application, and that is the one which coordinates and contacts with the other MapReduce jobs, and they have a negotiation with the resource manager to schedule task and all that. And there is container where all this node manager and all will run in, and which is what responsible to allocate all this memory, CPU, and other resources needed. So this is how the workflow will be. As you see, there is this YAN, which has a scheduler as well as application. And whenever a particular, the application manager takes care of executing all this, and scheduler is the one which schedules that particular node to start, executing. And node internally involves container and sometimes application master. So generally the sequence of job happens like this. You can see there's a sequential diagram we have put up here. Whenever your client submits an application, there is this resource manager allocates a container. Container is where your entire data processing happens to start the application master. And application master registers with RM. RM is resource manager, and application master asks containers from RM for any resource and all that allocation. Resource manager will have all the CPU and all memory controls and all that. And application manager notifies NM. NM is node manager to launch the other containers needed. And like I said, everything executes in your application container. So your code, your data also will be, your code and all will be executed in those containers. And your customer, your client here contacts RM or AM, either the resource manager or application master, to see how the application status is happening. Is it good? Is it bad? And you have certain monitors also. You can figure out how this entire processing happens. And finally, once all this happens and once the job completes, the application master unregister with RM so that it can start processing everything. Thanks for your time, everyone. See you. Bye.